It's really, really fun. Pictures. So if I look at a right triangle, let's just start with a very blank right triangle. At my 90-degree angle here, where would be my angle of elevation? Is it going to be in this bottom left corner or upper right corner? Where would I be looking up from? Bottom left corner or the top right corner? From the top, if I was standing here, I would be looking up. Yeah, if I was standing here, that's my sight line. It's going up there. So our angle of elevation is usually located at the bottom. So I'm going to put that theta there. Really bad looking one. We'll pretend it's nice looking. Okay, and that's our angle of elevation. We're looking up. So let's imagine this in the real world. Okay, I'm standing here. There's me. I'm a beautiful person. Look how pretty I am. So pretty. Okay, and then I'm standing on the ground. And here there's like grass because it's the ground. And I'm looking up at something.
Is it a circle?
It's the theta sign. It's supposed to be the circle with a line through it. Alright, so I'm sitting there on the ground, and I'm looking up at the sky, at something in the sky. What's something in the sky that I could be looking at? What do you got, LeVar? You don't look at the sky ever? The sun? Okay, we're looking at the sun. Okay, and I'm looking up at that sun. And then we're going to measure kind of how far down that would be, and that's basically usually on shadows with suns. When we deal with the sun, it's usually based on a shadow that we're working with. Okay, and this would be our 90-degree angle here. So where would my angle of elevation be? Is it going to be closer to me where I'm standing, looking up at the sun, or is it like the sun is looking down on me? No, not until Linnea gets back. So is the elevation going to be me looking up at the sun or the sun looking down at me? Yeah, me looking up at the sun. So this is our angle of elevation here, is at the bottom, looking up.
Just like the way it says horizontal line of sight. Usually we just look straight like a horizontal way. So elevation is like looking above the horizontal, upwards to the sun.
Good, because horizontal means, yeah, looking like straight ahead. All right, next up we have an angle of depression. So if elevation means we're looking above, where would depression be? Looking below, okay? If you have depression, usually you're feeling a little bit below, you're feeling a little under, you're a little lower.
Okay. Economic depression usually means that the economy is going down.
So depression is below our horizontal line of sight, or that we're looking down from the sky. So this time when we draw that horizontal line, this one the horizontal line was the ground. This time the horizontal line has to be from the sky. So it's going to go across the top. And then it's going to drop down. So that's where our horizontal line is across the top this time. Hi, after coffee. So the way that these triangles are set up is a little bit different because where that horizontal line is, it really matters. And then this time we have that angle of depression would be from this horizontal line down. right, so if I'm in a plane, ready to see my plane? Look at that plane. Dang, Miss Morrell, you're an artist. Yeah, I am. All right, now I'm looking down maybe like on a building. I'm sitting in that plane. I look down. I see this building down below. So I'm sitting on the plane. I look down at that building. The big thing is when we fill out the rest of this triangle, we want to think about where that horizontal line is going to go. And it's based on where we're starting or where our viewpoint is from. Our viewpoint in this one is starting from the sky looking down. So if I was in the sky and I was looking straight across, I'd be looking to the left there and then down. So our 90-degree angle would be here at the top. Okay, that's really important how we draw that triangle and fit it in. We can draw that triangle down below, but that's going to screw up our angle of depression. It won't work the same. So here's our angle of depression, looking from the plane down to the bottom. Okay, this is a building, if you're not sure what this is. It's a little house. All right, so those are our key words. We're going to do now 2 word problems. As we read these word problems, we're going to decide what's important for us to know, what are some big ideas, and then we are going to draw the pictures, and based on our pictures, we'll be able to then use our sine, cosine, and tangent to solve those problems. Although, phone away. Thanks. Appreciate it. All right, so here we go with the next one. It says, at a diving competition, a 6-foot diver, 6-foot tall diver, stands atop the 32-foot platform. The pool is 50 feet in length. A camera is set up at the opposite end of the pool. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation to the nearest degree? Whoa. So much happening in that. All right, so what are some of our important parts to this? Good, the diver is 6 feet tall. So 6-foot tall diver. What else would be our key information here? Good, 32-foot platform. That's the biggest one. That's the one that they do in the Olympics. That's our 10-meter. And what else would be important here? What's 50 feet? The pool is 50 feet, right? All right, what are we trying to find? What is it asking us to find? Good, the camera's angle of elevation. That's our goal, is to find that angle of elevation. All right, so we get to this chance to show this out, draw out a picture, decide what this is going to look like. As a diving coach, this is really relevant to me because, I don't know, it's diving. I'm not 6 feet, though, so maybe not relevant to me. Just kidding. I am a coach. I don't have to be 6 feet. So as a diver. Some of my divers are 6 feet. All right, so first off, when we think about this space that we're in, what's something that you have to imagine first? Probably imagine the pool, right? Okay, so we're in the water. We have this pool. So here's my water. See my water? Look how pretty it is. Water. And how long is that pool? How much length does that go? 50 feet. So we can put 50 there. All right, at the end of one pool is a platform. A platform is like the little thing that they dive off of. So here's the platform. How tall is the platform?
30.
32 feet. But standing on top of the platform, atop or on top of the platform, is what?
Plus 6.
Yeah, that extra little diver guy up there. And he's an extra 6 feet. Doriana. Doriana. Hi. Welcome back. All right, and then we have a camera that's on the opposite end of the pool. So where's the camera going to go? The camera is set up at the opposite end of the pool. So does it go under the platform or on the other end of the pool?
Other end.
Good, other end. So here's our little camera. Look at that camera. Amazing. That's not what they look like these days, but just pretend. All right, and the camera is looking up to which point? The top of the diver's head. So this is going all the way up to the top of the diver's head. How are we doing? Making sense so far? All right, so our goal first off is to figure out that this is a right triangle. So where is that 90-degree angle going to go? Where does the 90-degree angle go? Next to the 30, where the 32 connects with the 6? With the 50. Good, it's right where that platform. Hopefully the platform is going straight up and down, otherwise that diver's safety is in danger. Okay, and we're trying to find the angle of elevation. So where is that angle going to be? Is it going to be up next to this diver at the 6 round up there, or is it next to our camera? Good, next to our camera. So that's our angle of elevation that we're trying to find. So that's going to be our theta. So let's label our different parts here. Whoa. All right, so as I label the different parts, which one's our hypotenuse?
Remember how do we find our hypotenuse? Across something? 90 degrees. Alright.
Good, so that's our hypotenuse. What are the other two sides called? Opposite and adjacent. Good, adjacent. It's kind of a weird word.
So where would our adjacent go? Bottom, the bottom here. Right? So it's right beside the reference angle, so it's adjacent to it. How about opposite?
The angle we haven't gotten yet, the forward.
Yep, the one that runs it right across.
What do you mean we haven't gotten it yet?
We haven't run that side down yet.
Yeah. Do we have the whole side length written down yet? No, because it goes all the way up to the top of that diver's head. Nice, Carter. Good catch. So as I look at this whole side, the platform goes up 32, and then it goes up an extra 6 feet for the diver. So how tall is that whole side going to be? What do we do with those two numbers? Add them. We got 32 plus 6. 38. Is that what you said, Carter? I couldn't hear you. Yeah, she could go. All right, so if I'm trying to find our theta, I want to look at the parts that we're given. So the parts that have numbers. What are the two sides where we're given information? Good. Opposite and adjacent. This brings us back to yesterday. We can think of SOHCAHTOA. You need to write that off to the side here. SOHCAHTOA.
Which trigonometric ratio do you think you should use in terms of this triangle?
Good. What made you pick tangent? Good. We have opposite and adjacent. Do I know my hypotenuse? No, we don't know that one, so we don't want to use sine and cosine because that would not get us to that hypotenuse part. We need to use that angle. So we're going to use opposite and adjacent. So we're going to do tangent. So I'm going to say tangent of theta, or tangent of x, we could have used 2, or theta, equals. And what are we going to start with first? Opposite. So which number goes on top? 38 over 50. So opposite over adjacent. You need to make that little mark there to remind yourself what that is. All right, and our goal is to find tangent. We learned this yesterday. We did it real quick. So how would I undo tangent if I want to get just theta by itself? That's my goal. Yeah, use that -1 thing. What do we call that thing with the -1? Tangent. What does that -1 stand for? Inverse. Good. So we're going to do the tangent inverse on both sides. Okay, and this one is really good to use your handy-dandy calculator for. Okay, Desmos calculator is really nice because it's automatically already in degrees for us. Does anyone remember how to get to that inverse function from a Desmos screen? Good, go to function, tangent inverse, and then 38 over 50. And we get 37.23483398. What does it want our answer to look like? Good, nearest degree. So the nearest whole number. So nearest degree is just nearest whole number. So 37 degrees or 38 degrees? Good, 37.
For those who are still wondering, inverse is just a fancy way of saying undoing. Like if you want to undo adding, you just subtract. If you want to undo multiply, just divide. It's just a fancy way of saying that.
All right, we have one more problem. Number 2. This time we did elevation in number 1. What do you think number 2 is going to be about? Depression. Not the actual, sickness of depression, though. Angle of depression. All right, Maria is at the top of a cliff and sees a dolphin in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the distance from the dolphin to Maria to the nearest foot? So let's start with picking up those important parts of information. What do we see in this problem that might be important to us? What? The 40 feet? Okay. So the cliff is 40 feet above the water. What else do we see that might be important? Good. Angle of depression is 52 degrees. That's really all the concrete information they give us with numbers. What is it asking us to find? The distance from the dolphin to Maria. So that's going to be our unknown. And this time, is it a length or is it an angle? If it's distance, is distance a length or is distance an angle? A length, it's an amount. It's like a measurement that we're measuring there, not an angle. the space between. I don't know. My brain's starting to go dead. All right, Maria's at the top of a cliff, so we need a cliff here. I'm going to draw my cliff on this side here. Here's Maria. She's standing on the cliff. Maria. Look at that wonderful cliff. And below her is the water. Probably the ocean. Are there any freshwater dolphins? They're all saltwater, right? Okay, at the end of that water, what is she looking at way over there? She's looking at her dolphin. Look at that dolphin. Gotta make it look a little happy. That's a really good dolphin, you guys. That's like the best dolphin I've ever made. Alright, if you're not the artistic type and you're like, I don't want to draw a dolphin, you could probably just put like a letter D there to stand for dolphin, if that's going to make you happier. That dolphin makes me so happy. Look at it. It's so cute. Oh.
It looks like you want to die for you.
Well, sometimes you shouldn't swim with nature. Depends on where you are. Maybe there's rocks. Can't jump. No. Dangerous. You don't know if there's rocks or not. How deep it is. Alright. So this dolphin and Maria were looking at each other. Alright, and let's put in our measurements here. Where do we see is 40 feet? 40 feet is our cliff. But here's the problem is we're doing an angle of depression. So when you look at angle of depression, that means we're starting by looking straight across, and then we're looking down. Okay? If I look at this guy here, if I look at Maria, if she's looking across, is that looking straight down? No. So what we actually have to do here for Maria is we have to look straight across, all the way across there. And that's our angle of depression. Is from her looking straight across down to that dolphin. And how many degrees is that angle of depression? 52. So she's going to look straight across, and then we're going to drop straight down to where that dolphin is. And that's actually the triangle we look at. And that triangle's a little bit harder to think about sometimes with angle of depression, because when we draw that picture, the way my brain worked is it looked at this triangle first, this one kind of created below. But when you have angle of depression, we have to look across, and then we're looking down.
Now, even though it looks like you can make a triangle here too, again, it goes back to our definition of elevation depression, which is above or below the horizontal line. So it always has to be looking straight first.
And we're thinking the depression from Maria, so looking straight across from Maria. All right, our 90-degree angle is right where it drops down to that dolphin. All right, but this does create a rectangle, which is really nice, because then that tells us since this side is 40 feet here, what's this side going to be? 40 feet, yep. So this is also 40 feet. It matches. All right, and I'm trying to find the distance from the dolphin to Maria. So is that going to be the top part of this triangle or kind of this diagonal part of the triangle? Good, the diagonal part, so that'll be our x. All right, so as we take a look there, what are the sides that we're given? What does the 40 represent? Is the 40 the hypotenuse, the opposite, or the adjacent based on our reference angle 52? Good, it's opposite of the 52. It doesn't touch it, so that's our opposite. Okay, according to 52 degrees, is this x the adjacent or the hypotenuse? Good, the hypotenuse. How do we know it's the hypotenuse and not the adjacent? Good, it's across from the 90 degrees. Okay, if it helps you to label the last side adjacent, you can. It's your choice. All right, so which trig function, so, ka, or toa, are we going to use based on opposite and hypotenuse? Ka has adjacent and hypotenuse. So I want that S one. What's that S word again? Sine. Good. It looks like sin, but we say sine. So that's our opposite and hypotenuse. So sine of, what's our angle? 52 degrees equals. And then it's so it goes OH. Now again, if you're not sure, you can always look back in your notes. Otherwise, Mr. Kwan made that really nice whiteboard for us to look at. Sine is what over what?
40 over.
Good. What are the words we use for 40 and x? Opposite over hypotenuse. Good. All right, and our goal is to solve that for x. But there's a problem we don't like about this. What don't we like about this problem? Good. X is on the bottom, which is gross. Yuck. We want that x to be on the top, so I'm going to flip it. So I'm going to do x over 40. But if I flip one side, what do I have to do to the other side? Flip it. So I have to think of that sign as a fraction. And how would I flip sine over upside down? What is secretly below sine here? A 1. So if I flip it, where's the 1 going to end up going?
1 over sine.
Good. 1 over sine of 52. And then we solve it. So how would we undo now to get x by itself? We just have to get rid of this dividing by 40. Good. Times 40. And if we do it to one side? Do it to the other side. Good. I'm running out of space, so I'm just going to have to go down on my notebook here. All right, and again, if you don't use Desmos, if you're using your phone calculator, you have to be really careful to make sure it's in degrees. Now, on your computer, I noticed some of you are using the Graphing Desmos calculator, which isn't a bad thing, but the Graphing Desmos calculator does go into radians right away. So to get this fixed, up at the top, there's a settings button, this wrench. And at the bottom here, it has this radians and degrees. And we have to make sure the degrees is highlighted. Okay? So if you accidentally open up your graphing and you're like, oh, cool, it's just graphing, I can do the same thing. That's fine, but you have to make sure you hit the settings and make it in degrees. The scientific calculator, this one, is the one that's automatically in degrees for you already. All right, so 1 over the sine of 52. And then times 40 off to the side. And we get 50.7607286029. What did it want us to round to? Nearest foot. So just the whole number. So do we want to round it to 50 or round to 51? 51. Good. And then label that with that feet. Nice work. You guys crushed it. That's the end of notes for trimester 2. Oh, don't cry. It'll be okay. Yeah, in 2 seconds. All right, there is a practice today in Schoology. 8-5 practice. Next week, we are going to do a review on trig. And then you have your one-pager and your test. Your test is on Thursday. Friday will be a good day for you to get caught up on anything that you're missing, anything that you feel like you need.
Can I return all the papers?
Yep, everything is due by the last day of the trimester. So by Friday, next week.
I've been with the B plus the whole semester and I don't see exams.
You are. You just don't do your one-pagers. Yeah, I'm coming. Yeah, would that be easier? That'd be easier for me. right, the first part of the practice is going to be going over pictures and deciding which picture matches the right diagram. The first 3, and then the second 3, you're actually doing the sine, cosine, and tangent. We got 10 minutes right now. I know that's not a whole lot of time, but plenty of time for you to get started.